Hello, welcome again. In recent days, I have received a lot of emails from you that how we can install Aspen HiSys and Aspen Plus. But the answer is you cannot have these softwares without license. So there is a very exciting software that is free and open source, and you everyone can use that software without any problem. So the software name is DWSIM, and this is free and open source software that everyone, if you are a student or a teacher or independent consultant, you can just download this software in a few very easy steps. And on the other hand, this software has a great capabilities to solve complex chemical engineering problems, particularly if we talk about steady state simulations. And the layout of this program is very similar to the Aspen Plus. And definitely, if you learn this new software, so it will definitely add value in your resume. To download this software, just click on this link, and I also give this link in the description of this video. So just follow the steps that I am going to perform to download and install this software into my computer. And a good thing about this free open source software, that it does not require a lot of free space in your computer and a very high speed computer. So when you click the link, it will lead you to this official website of this software. Here you can just click on this button, download now. So, and now if you have Windows, so according to your operating system, if you are using 64-bit or 32-bit, or you are an Apple user or Linux user, so whatever the operating program you are using, so you just have to click according to that. I am using 64-bit, so I am going to download this one. Just click on it, and now you are ready to install. So it says your download will start shortly in 5 seconds. So just wait a bit. Okay, now the downloading already started here. Okay, now we already install the installer of this software. So it's not very heavy file, you can see it's just only 144 megabyte file. Just right click on it and run as administrator. Okay, sometimes your Windows is going to will not allow to install this, but just click on this and say run anyway. So select your language, what you would prefer. So I am going to install it in English. Press next. Next. So instead of DWSIM, there are three other options. ChemSep, that is a specialized software for distillation column design. So we will install all these three capabilities of this to enhance the overall performance of DWSIM. Just press next. Next. Okay, and now just it will install in maybe few minutes. Okay, here they are asking for license agreement for ChemSap. So just say I agree, and install for anyone using this computer, and just press next and install it. Press next, finish. Okay, now there is another software. Actually, it's the chemical properties library. Just press next and accept the license agreement. Press next. For all user of this machine, install. Okay, now we successfully installed DWSIM version 6.4.6. that is the latest available version at the moment. So just finish. Okay, after installation, so now it's time to solve our first problem in DWSIM. So for that, today we are going to solve a problem related to the shortcut distillation method, which is Fenske Underwood Gilliland method we will use to solve this problem. So there is a feed that is consisted of propane, isobutane, isopentane, N-hexane and N-heptane with this mole fraction that is given in this table. Here the light key component we are considering isopentane, and heavy key component is N-hexane. The overall feed flow rate is 2500 kg mole per hour at a temperature of 30 degrees C in the form of saturated liquid. The distillation column operates at feed pressure, and in distillate, the heavy key component, that is N-hexane, should not be more than 0.01 mole fraction, and the light key component, that is the isopentane, should not be more than 1% in bottoms. And using DWSIM, we are going to find out what would be the minimum reflux ratio, what are the minimum number of stages for this separation, and actual number of stages, and optimum feed stage location. So these are four unknown that we will find after solving this problem in DWSIM. So let's go to the DWSIM software. So when you run DWSIM, the first window that appears would like this. So to start a new steady state simulation, you have to go in file menu and new process simulation model. Just click on it. Okay, so then this new wizard will open, and simulation configuration wizard, just press next. Like in Aspen HiSys or Aspen Plus, the first step is you have to specify all the components which would be involved in your simulation. So in our case, these are propane. So just write here, and from this column just click on it, so it will automatically be added into the simulation. Okay, after propane, next is butane. Okay, and that is isobutane, and then write pentane and select isopentane, and then hexane and select normal hexane, and in the end heptane and select n-heptane. Okay, so now we have selected or added these compounds in our simulation, that is propane, isobutane, isopentane, n-hexane, n-heptane. Okay, after selection of compounds, just press to the next button, and now you are in property package environment. You have to select according to your system, as we have a hydrocarbon system, so the ping Robinson would be a good option. You can click on it and press this add button. So now the property package is selected for this simulation. Press next. Now we are here. It gives you a freedom to choose which kind of units you would like to work. Here it has many options like System International, English units, and there are some customized sets. You can change whatever you want. For example, for this case I am going to choose C5, which has almost all the units in which I want to work. Okay, so after unit selection, just press this finish button. Now we are ready to construct the flow sheet. For that, the canvas is very like to the Aspen Plus. So from this bottom ribbon you can have streams: material stream, energy stream, pressure changing vessels, that are orifice plate, compressor, pump, expander, valves. Similarly, separators, mixture, exchangers, reactors, columns, and many more. Okay, so we need shortcut distillation column. So just go to the columns, and from there press this shortcut column and drag it into the simulation environment. Okay, after that we have to put here 3 stream. One is feed, okay, and second one is distillate, third one is bottom. So these are 3 material stream, but we have to introduce 2 energy stream. One is for reboiler duty, and the other one is for condenser duty. Okay, so when you place all the material energy stream and put the shortcut distillation column, now it's time to connect this stream with this column. For that, just press on this shortcut column, and from left side of this here at the top, you can change the name of the unit operation. We can say distillation column. Okay, press enter. So here you can see the name is already changed. After that, just connect material and energy stream. For that, go to the connections on this drop down menu. So the material stream 1 is as a feed, material stream 2 is as a distillate, material stream 3 as a bottom, and condenser duty is 2, and reboiler duty is 1. Okay, and so when you connect, after that you can change their name. Okay, so for example, I just click on this material stream 1, and from this left window in front of object, I am changing its name to feed. Press enter, and here this one, material stream true, again just write distillate. Okay, press enter, and here material stream 3, go again on the same point and write bottoms. Press enter. Okay, similarly for energy stream, so this one is condenser duty, so we can say C duty. Okay, and here this one is reboiler duty. Okay, so we can say R duty. Okay, so we change the name of all these stream. Okay, now it's time to specify the feed stream composition and the condition. For that, just click on the feed, left click, and after that from input data go to the stream conditions, and from here there is this tab flash spec. From this, just click on this drop down menu, and from here you have to select temperature and vapor fraction, because it is written in the problem statement the feed is a saturated liquid at a particular temperature. Okay, so that's why we are using temperature and vapor pressure flash. Okay, so what is the temperature? The temperature is 30 degrees C. Okay, so just press here 30 degrees C, and the molar flow rate is 2500 kg mole per hour, and the vapor phase mole fraction, we will have to press here 0, because the feed is saturated liquid. Okay, so when we specify the temperature and vapor fraction condition, now it's time to specify the mole fraction. For that, go to the input data, from there stream condition, and then compound amounts. Usually by default DWSIM take the equal value of each compound which are given in your problem, but from here you can change. For example, here we already selected basis as a mole fraction, but you can change it mass fraction, mole flow, mass flow, standard liquid volume flow, molarities or molalities. So whatever the data you have, you can according to play it. Okay, so it's already selected mole fraction, and now it's time to put the mole fraction of feed stream. Okay, so for that, just again recall from here, propane is 0.05, so I'm going to put it 0.05, and isobutane 0.1, and isopentane was 0.4, and normal hexane is 0.36, and the last one is 0.09. Okay, and after putting your composition, just press accept changes. Okay, now the feed stream is fully specified according to our given condition that are asked in the problem statement. Okay, next step is we have to specify shortcut distillation column conditions, and here in this problem you do not need to specify the condition for distillate stream as well as for bottom, and similarly for condenser duty or reboiler duty. All these parameters will be calculated by the software. So to specify shortcut distillation column, just left click on it, and then this window will be open on left side of the simulation. So the first thing that we have to do, we have to tell the system which one is the light key compound. Okay, so light key compound is isopentane. Okay, from here isopentane, and the heavy key compound is n-hexane, and we want light key compound mole fraction in bottom should not be more than 1%, so that is equal to 0.01 in mole fraction. And similarly we want heavy key component in the distillate system should not be more than 1%, that is again equal to 0.01%. so these are the values that by default DWSIM enter, but you can change it according to your question. For this problem we are using total condenser and condenser pressure and reboiler pressure. We will operate a column on the feed pressure, that is from here you can see it is 1.4 bar. So just change pressure here, 1.4 bar, press enter, and similarly 1.4 bar, press enter. Okay, so everything that was required to solve this problem we enter. To run the simulation, press this F5 key or solve flow sheet button, and the simulation is already converged successfully. Now let's go to the results. Okay, in problem it was asked we have to find minimum reflux ratio, minimum number of stages, actual number of stages, and optimum feed stage location. Okay, for that, when you click the shortcut column, left click, then go to this window left hand side. Okay, and from here results, you have minimum reflux ratio, minimum number of stages, actual number of stages, and condenser duty, reboiler duty. Okay, so we have all the results here. Another thing, because it was asked in problem statement that in distillate the heavy key component should not be more than 1%. To check this one, just click on distillate, go to the compound amount here. Okay, and you can see here the n-hexane, that is the heavy key component, is 1%, that is not more than 1. Okay, so this was asked. Similarly in bottom, the light key component should not be more than 1%, so it's already 1%. So we specify all the given conditions and solve this problem successfully in DWSIM. Okay, so if you want to generate a result report for the simulation, it's very easy. For that, you just have to go here in the top ribbon and press results, and then press create report. Then this new window will be open. So what do you want to put into your report? So we want material streams, energy stream, and shortcut column, and what we want for each stream, what kind of properties should be present. So you can select from here, include condition, molar composition, mixture properties, include vapor phase properties, and many more. So after selecting all your desired properties, you just have to view report or export data to a file. So if I press view report, okay, so it will tell you the total number of pages are 7, and the simulation report, for example, for feed stream all the properties and their value is given here. Okay, so it's very easy, very similar like to Aspen Plus, and it has a lot of liberty to introduce your own model if you know the Python language. So there is a window for where you can introduce your own model using Python computer language. So that's all for this DWSIM tutorial, and in coming tutorials I am going to use the same software because it is open source, it is free, and everyone can has access, easy access, and just learn something new. Okay.